Hey, Physics people. So here is a question that I'm going to go over. Qualitative, quantitative question. It's pretty tough one. So let's go over piece by piece. Okay, so we have a block sliding down this ramp. Now it hits some frictional surface and it slides. And the initial one, it comes to a stop at 4D. All right. So this is the question, and what we're giving here, all of our answers are going to be expressed in the terms of D, and we have the coefficient of friction, UB. All right. So the first question asked for us to graph the kinetic energy of the block and the potential energy of the block from starting at negative D to 4D when it comes to a stop. Okay, so let's do the first one in red. All right, we'll do kinetic energy first. So if it's at the top, kinetic energy is 0. Now it's going to go up, and let's just pick, it's arbitrary what we pick here. Let's pick this point right here. All right, so the kinetic energy increases, so it's the most right at the bottom. Okay, now it hits the bottom of the ramp, and what happens? Now the kinetic energy is decreasing, 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 all the way to 4D. All right, so it's coming to a stop. Now potential energy. Let's do potential energy real quick. All right, so let's do that in blue. All right, potential energy, it's max at the top, and it goes down the ramp, and the potential energy is 0 at the bottom. So we would just label these U for potential and K for kinetic. All right, so we have that now. Let's move on to the next part. So now we have a question here. So let's read this. So we have the block is released from top of a new ramp that has a base of 2D, but still makes an angle of theta. So with the horizontal. So let's draw that. So we're going to draw that. Let's draw two scenarios. So first scenario is we have, this is the ramp, D at some angle. Now they say that, okay, let's make the D, this one 2D. And we got the same angle here. So now we have a new height. All right, so here's our second scenario. So let's go back to this. So the student reasons that since the block will be released from a new height that is twice as high as the original height, the block will have more energy when it reaches the base of the ramp. So it will slide further along the right surface before stopping at x is equal to 8d. With which aspects of the student's reasonings, if any, are correct? If no aspect of the student's reasoning is correct, write none. Okay, let's see if the first thing that he writes is the block will be released from a new height that, from a new height that is twice as high. All right, let's see if that's true, if the new height is twice as high. So is this height twice as high? Well, let's do this one first. So this looked at, we have the, this is D as well. So we have, this is D, and this would be 2D. All right, so is the height twice as much? So what trig function are we going to use? Well, we got opposite and the hypotenuse. So I'm going to say, we'll call this H1 and H2. So if we do tangent of theta is equal to opposite, which might H over d. So h1 is equal to d tangent of theta. Over here now, we have tangent. Remember, this is the same theta. So tangent of theta is equal to h2 over 2d. So h2 is equal to 2d tangent of theta. So if you look at this, h2 that's 2 times h1. All right, so that first part, that's what he did have something correct, of that the height is going to be twice as high. All right, now let's do this one. So the block will have more energy when it releases, or when it reaches the base of the ramp. So it will slide further along the right surface before stopping at position 8. All right, so the so does it have more energy? So let's do another page here. So it's saying for the second scenario that it's going to have more energy. Okay, so do scenario 1, scenario 2. Okay, in scenario 1, we have mg. We got all the potential at the top. So mgh1, and that's going to equal to all the work to stop it. So the work to stop it, remember work, will be done by my force times my distance. Okay, and we're given here that this distance is 4d. All right, so my frictional force is mg times mu of b. This is my normal force. Remember, frictional force is my coefficient times my normal force. So if my normal force is mg, my coefficient is mu b. Okay, so here I have mg mu b times 4d, because it comes to a stop at 4d. And here we have mg, and we did h1. If you look at h1, h1 was d tangent theta. So d tangent theta. Here we got mg ub times 4d. All right, mg's cancel out because they're on both sides. D cancels out because they're on both sides. And so now what you get here is we have an expression here, and we're going to come back to this in a second. Tangent of theta is equal to mu over b is equal to 4. Okay, I'm kind of jumping down to the second part down here. Let's look at this real quick. Before we got to that, this is going through and deriving the equation. But I think I can do something easier here. So when it asks for will it slide right before stopping at x is equal to 8d, and that one's correct because we can just state it like this. So energy to start is equal to energy that we end with. So if I double my energy to start, then I double my energy to end with. So therefore, if my initial work was equal to F times 4D, if I double that, if I double my work, then I'm going to double my my distance, so that will go 8D. All right. Okay, So let's go back to, let me get a bigger eraser here. Let's go back to this. All right, so the next part, this is what we've already started asking this. Oh, for part 2, which aspect of the student's reasoning is incorrect? Well, none of it. None of the, he said everything right. So nothing is wrong there. Um, so here's part C. Here's where we're actually deriving the equation. And we already started doing that. So we want to express our answer in D. So we're trying to derive that, that it stops at 8D. With the new height. So if you look at this, let's go through and write with a different color. So this is the first scenario. The second scenario, we doubled, so we doubled the height. So we have 2mg, but remember our height here was d, like if we remember here, our height was d tangent theta. So I'm going to put that here. D, oh, whoops, all right, capital D. D tangent theta. Okay, this is my initial energy. And my final energy is going to be, remember, this is your work. So it's going to be F times the distance, that's my frictional force, times the distance it travels. And we don't know that distance yet. We're trying to derive it. So I'm going to put an X there. All right, well, my frictional force is my coefficient times my normal force, which is mg. Let me rewrite this stuff down over here. All right, so I'm going to cross out a couple of things here to make it a little easier. These cancel out. All right, so now let's isolate x on this side. So we got x, we have 2d, and we have tangent theta over mu b. All right, so here we go. The last step here is we can substitute this in. If we have tangent of theta is mu over b, I can sub that in, and I get 2d times 4 is equal to x. Whoops. So therefore, you can see x is equal to 8d. So we verified, we derived the expression for that block coming to a rest. Okay, last part, we'll just read over this. So now it's asking you to use the math that you did and justify the reasonings. This is actually a really difficult one. So I'm going to bring up the example response that they had. All right. All right, part D. Okay, here's it. Well, let's read up what to get 1 point for each one of these. So 1 point is earned for indicating that the student's reasoning that the block has more energy in the second situation is expressed by calculations comparing the initial gravitational potential energy in the Earth block system. All right, so really easily said, like U of 1. So your second potential is equal to double your first potential energy. All right, so that was expressed in your in the formulas that you had before. All right, the next one, 1 point is earned for indicating that the block will slide farther distance 8d because there's more work done by friction to stop the block when it slides down the new ramp. All right, so here's an example response. So I'm going to just read this out. The student claimed that the block would have more energy in the second situation, which is demonstrated in my mathematical relationship when the height of the ramp doubles and it increases the gravitational potential energy in the block Earth system. Also, the student claimed that the block would slide to a distance 8d, which was expressed by the work equation I wrote, which shows that the work done by friction to stop the block is twice as much as the work needed to stop the block the first time. All right, so we got, remember, potential energy doubles when you double the height. And if you double the potential energy, you double the amount of work that's needed to stop it. And since the force of friction stays the same, what has to double then is the distance. Okay, hope this helped.